Hello, my name is Luis Salazar, and I will be solving this problem or these problems. I am a little sick, so I'm sorry. So the problem says the tank has a shape of a cylinder with a radius of 8 meters and a depth of 3 meters, and then the water is at standard density. So the first question says how much work is required to empty a full tank, and then the pump is at the surface of the tank. So what we need to know is this formula right here. The integral from A to B of P times surface area times gravity times the distance. So P is essentially the density. So it says water is at standard density. So that would be 1,000. The surface area would be pi times 8 squared, because the radius is squared, and to find the surface area, you would do radius squared times pi, and then you do gravity, which is 9.8, and then distance. And it says the pump is at the surface of the tank, so we know it's going to be 3 minus y, and then dy. So from here, we have to know what's A and what's B. So since it has a depth of 3 meters and the tank is full and we want to empty it, it's going to be from 0 to 3. 0 to 3. So what we're going to do here is we're going to solve it in terms of pi. So what we're going to do is we're going to square this 8, and we're going to multiply that by 1,000 and 9.8. So that's 1,000 times 8 squared times 9.8. And that gives us 6,272,000. So 627,200. And we had to put pi, because there was a pi right here. And then the integral from 0 to 3 of 3 minus y dy. Oops. So now we have to find the antiderivative of this. This should just be 3y minus y squared over 2 from 0 to 3. And that's all being multiplied by this number. I'm not going to rewrite it. That's going to take a lot of time. So now we just plug in 3. We can plug in 0, but you'll just notice that you end up just getting 0, so there's no point. So when you plug in 3, you get 9 over 2. Then we're going to multiply that by the 627,200.
¿Quieres galletas? No sé qué trajeron.
Okay. And then you end up getting this. And then we can't forget the pi. So in terms of pi, the answer would be 2,822,400. And if you were to multiply it by pi, you would get 8866,831.105 joules. Can't forget the joules. It's in joules. And that's the answer for number 1. Okay, so it says how much work will it take to empty the tank if it has water at a depth of 1 meter, pump at the surface of the tank. So this is going to be similar like the other problem, except from the integral it's going to be 0 to 1, because it has a depth of 1 meter. It still has a depth of 3 meters, but the water that we're pumping out has a depth of 1 meter. So everything's going to stay the same. There's going to be pi times 8 squared. And the distance is also going to stay the same, because the distance matters at where you're pumping at, and it says that it pumps at the surface of the tank. It's a y. So now, a lot of these numbers are the same. The only difference is this one. So if we were to rewrite what we had before, we had 627,200 pi times the integral from 0 to 1 well, times 3y minus y squared over 2 from 0 to 1. So when we plug in 1, you get 5 over 2. And when you multiply it by the number on the outside, you end up getting you end up getting 1, 5, 6, 8, 0, 0, 0. Yeah, pi. And we can't forget that pi, and we can't forget it's in joules. If we multiply it by pi, we would get 4926017.281 joules. Can't forget joules, that's its we're calculating the work. For the last question, it says if a pump is resting 5 meters above the surface of the tank, how much work would it take to empty a full tank? So this is from 0 to 3 because it's a full tank, and we know it has a depth of 3 meters. Times 1,000 times 9.8. These numbers, 1,000 and this 1.8, are always going to stay the same unless they tell you that it's different. Times pi times 8 squared. And this is where this thing is different. So since the pump is resting 5 meters above the surface of the tank, you would do 5 plus 3. So this would be 8 minus y. So again, we're gonna multiply 1,000 by 9.8 by 8 squared, and that gives us again 627,200 pi. Can't get the pi. And then we're gonna go ahead and find the antiderivative of 8 minus y, which should just be 8y minus y squared over 2 from 0 to 3. So when we plug in 3, we end up getting 39 over 2. And when we multiply that by 627,200, we end up getting 1, 2, 2, 3, 0 pi joules. So this ends up being our answer. And then again, if you multiply it by pi, you would get 384,22934.79.